Welcome back to a lecture series on hydrogeology. So in this lecture now we are going to discuss about the stratigraphic control of groundwater exploration or groundwater exploration, how stratigraphically it is controlled. We'll see the stratigraphic control. This is the map of the groundwater province of India, and this is groundwater province is categorized with respect to various rock types like alluvium, laterite, basalt sandstone, shale limestone, granite, charnocite, quartzite, gneiss, intrusives, banded gneissic complex. So this is the general with respect to lithology. So this is being given by CGWB. So on courtesy, we are now representing here, and this is the first slide of groundwater exploration. In this now you'll be able to see this is being prepared after oral sing. India, as we know that it is diversified geological, climatological and topographical setup. This gives a divergent groundwater situation at different places in India. The prominent rock formations it is ranging from very old to the recent, archaic to the recent. So it controls the different rock types controls the movement of groundwater, and it is widely varying in composition and structure. The mountain terrains of the Himalayas on the top, to the flat terrains in the middle, and alluvial plains in the northern river valley, and the coastal tract all along the coast, and the Eolian deserts in Rajasthan are no less important with respect to groundwater is concerned. And we will see the details of these divisions in the subsequent slide. So the division set above is this. There are 8 divisions according to Dr. Oral Singh in 1971. He has divided the India into 8 groundwater provinces. The one represent Precambrian crystalline province. The second represent Precambrian crystalline sedimentary, Precambrian crystalline and sedimentary, Gondwana sedimentary, Deccan Trap, Cenozoic sedimentary, Cenozoic fault basin, Ganga Brahmaputra basin, and Himalayan basin. So we will see in detail about every divisions of this geological province. So this is the first one, Precambrian crystalline province. It is distributed in yellow in color. It is mostly from the places like Tamil Nadu, Andhra Pradesh, Karnataka, Maharashtra, Dandakaryana, Bundelkhand, and Aravalli range. So most of these areas are igneous and metamorphic in group. Groundwater is mainly in this area is restricted by the presence of joints. The weathering as an average, because with respect to the entire area, the weathering goes up to 30 meter. Groundwater occurs under water table conditions in this area. Groundwater occurs under semi-confined and confined condition depending on the depth and nature of the fractures in different locations. Normally, this is not good place. It is a deficient place with respect to groundwater resources. So in Precambrian crystalline, it's not much expected groundwater. And the second one is Precambrian sedimentary province. So the orange color represents the Precambrian sedimentary province. This is Precambrian, the center part. This is Precambrian sedimentary. This zone is present mostly in Kadapa, Raipur, Vindhyan, Western Rajasthan region. So this is mainly composed of limestone, shale, sandstone, quartzite, and local conglomerate. Normally in this area, we expect secondary porosity developed because of coarsification process of calcareous rocks yielded a copious supply of groundwater. Groundwater is largely limited up to a depth of 150 meter. Yield is varying between 5 to 200 cubic meter per day. It is not much suitable for groundwater development, but you will be able to get good amount of water. But in terms of quality, we will have to be very careful in this area because of calcareous nature. Coming to the Gondwana sediments, so this is the Gondwana sediments. 1, 2, 1, 2, 1, 2. This is Precambrian, and this is Gondwana. The Gondwana sedimentary rocks of the Barkar and Godavari river basins contain good aquifer. Yes, Gondwana normally it has good aquifer. This province occurs as disconnected patches mainly fluvialite, lacustrine sediments of sandstone, shale and with a little amount of limestone is also present in this. The total thickness of the formation it is ranging from 6 to 7 kilometers in this area. These rock formations are classified into lower and upper formations. Lower Gondwana is compact and it is devoid of water because of the source of compact in nature, compact of shale, so permeability is less. Upper Gondwana sediments are very good aquifers. It is because of more arenaceous. This is because of more, I mean, shale component here. Water table normally present here within 30 meter, dug wells and productive sandstone yield maximum amount of water here. So this portion is Deccan Trap. So now we have studied these portions and now we are moving to this portion, Deccan Trap. This normally comprises of basalt. It is normally hard, massive trap, vesicular trap, tough breccias, hash and intertrapians are found here. 1,200 meter thickness it is noted here, covering of impermeable basalt over the surface, which obstructs the percolation of water. As such, the whole province is deficient. The whole province is deficient in groundwater resources. The only aquifers preserved are here because of the fracture only you will be able to get. Groundwater occurs under water table conditions of weathered and jointed in this region. And Xenozoic, it is a Xenozoic sedimentary province in Tamil Nadu and Kerala as well as in Gujarat, Andhra, Kerala, Tamil Nadu coastal fringes of Saurashtra and Kutch peninsula. In the east coast, the seaward dipping strata contains several artesian aquifers. This province is characterized by sandstone and shale. Shale is the more compact, impervious and yield little water. The sandstone and conglomerate are highly permeable and yield about 150 cubic meter. Example, Kadalur sandstone. Springs are also developed in hilly tract. These have tertiary because of tertiary sediments and sedimentary rocks. This supplies good amount of water, but near the coast, the seawater intrusion will be the issues in most of the areas nearby coast. But in general, it is a good aquifer. And the Xenozoic fault basin, these two are a Xenozoic fault basin. It is found in Narmada, Purna and Tapti Valley. This is composed of sand, gravel intermixed with silt and clay affected by fault. This one thickness ranging from 50 to 150. These lenses are found sand and gravel and yielding good aquifer. Ganga Brahmaputra, which is located in the northern part, richest groundwater province. The next most extensive province covering almost in the entire northern plate, four step and crustal buckle. The basement of the hard rock alluvial ranging from 1 to 3 degree. The physiographic and hydrological, there are three alluvium, good groundwater aquifer in three distinct physiographic and hydrological belts such as talus material, hill slope and so this is the area where you will be able to get your good. And the second one, Ganga Brahmaputra alluvial basin, that is on the top of it, permeable water bearing gravel, sand, pebble. The actual belt which comprises stratified fine gravel silt. So the thickness is 10 meter below ground level, and wells have recorded free flow from 100 to 300 cubic meters of water in this area. And Himalaya, this is on the north, highly folded faulted rock because of the limestone, sandstone, shale and their metamorphic equivalents. This province, it is good with respect to the yield of 100 to 200 cubic meter. So with this, the lecture comes to an end with respect to stratigraphic control. Thank you.